Hi and welcome. It's Pearson, the science teacher. So as you can see, today there are just 3 questions that I want us to do together. And these questions are coming from the 2023 past paper. That's chemistry 50-70. All right. So before we go any further, I would love you to pause the video, and when you pause it, attempt, then come back so that we can answer together. So I want to believe you paused and you have your answers. Let's now answer together. So let's start number 7. Number 7 reads, which diagram shows the electronic configuration of an oxide ion? All right. So an oxide ion is an ion formed when oxygen gains its 2 required valence electrons. All right. So when oxygen gains 2 electrons, it's going to be stable and it's going to have 8 electrons in its outermost shell. So that's key number 1. We are looking for one of these options where it's going to have 8 electrons in its outermost shell. All right. So if we had to check, you're going to see that this one has 8, this one also has 8. All right. And this one also has 8. So this one is disqualified, first of all right, because it has 6 in its outermost shell. So we were looking for that one that is going to have 8, because we're talking about the stable state of what? Oxygen. So hint number 2, this diagram here is also disqualified because it's not an ion. It doesn't have a charge. Remember, in one of our lessons we said an ion is a charged particle of an atom, and this one doesn't have any charge, so we don't know if it's positive or negative. So this one is neutral, and if that's the case, going to the periodic table, we'll find that then this one will not even be oxygen, will be neon instead. All right. So what about this one, B? If you look at B is also disqualified because it has a positive charge here. All right. The positive charge means that atom has lost electrons instead of gain. All right. So any atom that gains electrons becomes negatively charged, and anything that loses electrons becomes positively charged, because it means the number of positive particles in it are more than the number of negative particles. So when electrons are more than protons, that atom becomes negative, and the opposite is true. All right. So here we get to know that our answer is actually A. Why? Because of that negative charge and this stability. So A is the diagram that shows the electronic configuration of an oxide ion. So 1, an oxide ion is expected to be negatively charged, and the number 2 there before the charge, the negative, shows the valency, shows its combining power, the number of electrons that it has to gain for it to be stable, and that's it. If you count the electrons in the outermost shell there are 8, which means 2 are just gained from n metal or non-metal by ionic bonding or covalent bonding respectively. So that is it for number 7. Number 8 reads, the oxide of metal X is X2O3. Which of the following equations represents the reaction of metal X with dilute hydrochloric acid? Okay, so we have 4 options there. What we need to do first of all here is, of course, allow me first of all to do with my video, is to know that metal X, this metal X has this oxide given to us, and what this means is that X has a valence of 3 and O has a valence of 2. So when they swap valences, that's when we end up having this chemical formula X2O3 or X oxide. All right. So when this X with a valence of 3 reacts with hydrochloric acid, the product is what we must be so interested in, because that's what is going to guide us to this correct answer here. All right, so let's try and react them. X plus hydrochloric acid. What we are going to have is X chloride, since it's a metal, plus hydrogen. Right? Now, we remember that the valence of this X is 3 and the valence of chlorine is 1. So they're going to swap the valences. They're going to swap the valences. So the 3 is going to come here. So the correct product is going to be X chloride, and it's going to have this. So if we go back to our options here, we get to see that from these options, A is correct. Already, A is correct, even before you go to the aspect of balancing the equation. A is correct because it's the only product where we get X chloride written correctly, because we know the valence of X here. So if we had to balance this equation, what we're going to do, now we have gone into balancing. A is correct there because this is what we'll get for real. But what is the balancing going to be like? So allow me to rewrite here. So X plus hydrochloric acid, it's going to give us X chloride plus hydrogen gas. All right, so we have 3 chlorine atoms here. Okay, so why do we put 3 here? We don't put 3 here. And we have this. So basically, here what we are going to have is we can have a 3 to make hydrogen 6, and then we'll easily write a 6 here. And this 6 means it's for everything, including chlorine. So even chlorine atoms will have to be 6. So let's look for a number that we can multiply by 3 to have 6, and that will be 2. So 2, yeah, 6. So even X, this side also we are going to have. If you go back to our answers, you're going to find that that's now the exact way the answer is presented there. So this is what to do. So once again, allow me to take you through. When you know the valence of metal X and you know the valence of chlorine, then you easily arrive to your correct answer, which happens to be A. I hope A was your answer. Okay, and now we are going to number 9. Number 9 says, which of the following particles has the greatest number of electrons? Simple. Which one has the greatest number of electrons? Wow. The first option there shows beryllium. Now beryllium has the following atomic structure. It's 2 and 2. Okay, now in this case, in this option here, beryllium has lost these 2, so it only has 2. All right, because it's a metal, and there's a charge there in the 2, which shows that the valence is 2, so it has to lose 2 electrons to be stable, and there it is stable, so it is an ion. All right, so beryllium has 2. We know beryllium has 2. What about oxygen or oxide? So oxide there, since it's stable, oxide has gained 2 electrons, right? Because of the way it is written, it means it has gained 2 electrons. So in the first shell, we have 2. In the next, we have 6 when it's not stable. But when it gains 2 electrons, it means we are going to have 8 in the last shell. So 8 plus 2, so we are saying oxygen has how many? 10. Okay, 10. What about following? We have N a negative, right? That's what we have there. So this means that it has gained 3 electrons. So according to the electron configuration, we have 2 in the first and we have 5 in the second. So now that it has gained 3, it means it's having 8 here, all right? So it means it has 8 in the last shell, so which means it also has 10, all right? So 10, okay. Let's go to the other one. That's sodium. Sodium has 11. If we just go straight to the periodic table, we're going to find that sodium has 11. So we find that A is showing the particle with how many electrons? 2. B is showing that particle with 8 electrons, 10 electrons altogether, 8 in the last shell and 2 in the first, so 8, 10. Okay, then we have we have 10. Then the third option is showing this particle that has 10 again, all right? Then the fourth option shows sodium with 11. So definitely there, D is the correct answer. All right, based on these ideas, D is the correct answer. I don't know what your answer was. I believe and trust that we've been following the previous lessons, and if that's the case, then we know that D is the correct answer. Thank you.